Today, healthcare and life sciences generate an extraordinary volume of data. According to an estimate by McKinsey, healthcare industry produces about 36% of global data, which amount to several thousands exabytes. Now, when we say data, you may be familiar with clinical trial data, electronic health records from hospitals and lab research. But today, healthcare data goes far beyond this. It includes routine care data from real world evidence, genomics, imaging, claims, wearables, and patient generated data. But here's the thing, the healthcare industry cannot fully realize the value of data if it is not structured, standardized, and interoperable. In simple terms, the remains trapped at the point where it is created. And when data doesn't move, it fails to deliver value. To respond to this challenge, healthcare organizations are building unified data models. So, what is a unified data model? At its core, a unified data model is a common way of organizing healthcare data. Let's say we have a data related to a patient coming in from electronic health records of a hospital, wearable app that monitors the patient, from a diagnostic lab where the patient gave a test, and the disease registry. Each of these sources capture patient data in different formats and structure. A unified data model standardizes how this data is represented. Data coming out of a unified data model can be used by analytics platforms and clinical decision systems without the need for repeated manual translations. Understanding how unified data model work is one thing. The more important question is why they matter so much to healthcare today. To answer that, let's look at few areas where their impact is already clear. RWA, unified data models make it possible to process diverse real-world data. Healthcare systems became increasingly digitalized post-2010. Within the clinical research ecosystems, regulators, payers, and life science companies wanted to go beyond clinical trial phases. They wanted to observe how therapies performed in real patients over longer periods and across routine care settings to understand real world effectiveness, safety, and value beyond controlled trial conditions. This is where unified data models played a major role. They brought fragmented care data into a consistent structure. That consistency made real-world data usable at scale and reliable enough for analysis and decision-making. Secondary data use. Unified data models make evidence traceable and defensible. In healthcare, some decisions depend more on context and consistency and traceability. This becomes especially important when data is reused beyond its original purpose. In areas like post-authorization safety studies, label expansions, and health technology assessments, the key concern is not speed. It is whether the evidence can be traced back to its original source and trusted within confidence or not. Unified data models make this possible. They preserve structure and meaning as data move across systems. Third is pharmacovigilance. Unified data models provide a coherent global view of risk for safety teams. Safety operations pull data from many places like clinical trials, spontaneous reports, healthcare systems, literature, registries. Each source shows only part of a picture. Unified data models bring these pieces together into single analytical view. This allows safety teams to focus on single review instead of constant reconciliation and maintain a clear global view of risk across large and distributed programs. Some of the enterprise-grade implementations of unified data models in healthcare include IBM's Unified Data Model for Healthcare and Innovaccer's Unified Data Model. Both are designed to bring fragmented healthcare data within an organization to create a single consistent view. This makes it easier to run analytics, apply AI, and reuse data across clinical and operational work. Deloitte, in collaboration with AWS, goes a step further. It has rolled out converged health, through which data can be shared securely and smoothly across organizations without the need of centralization. This enables a new level of collaboration and insight generation across the healthcare ecosystem. If you are a life science graduate who wants to prepare for new age careers in healthcare, you can check out the courses we offer at CliniLaunch. Through our courses in clinical research, medical coding, AI/ML in healthcare, and bioinformatics, we focus on developing skills that are aligned with the industry needs. Exploring these areas will give you a strong foundation to build a future-ready career in healthcare and life sciences. Thanks for watching this video. Subscribe to our channel to watch more interesting videos on life science industry and careers. Thank you.
Visit us today, www.clinilaunchresearch.in.